All right, this is 4th grade, Module 5, Lesson 25, and in this lesson, students are going to be taking fractions greater than 1, and generally they're going to be mixed numbers. Us old fogies would call them mixed numbers. I guess they're still called mixed numbers in Common Core. Anyway, students are going to be taking these mixed numbers and converting them into fraction form. In the olden days, we used to call them improper fractions. Now we just call them fractions greater than 1. In particular, we're not really using the standard algorithm quite yet. We're going to be getting there by the end of the video, but we're going to initially start using a number line to have students have a chance to make sense of what's going on. So let's get going.
So we're going to draw a number line to show our thinking. So the idea is we want to place 4 2/5 on a number line. So I'm going to draw, let's see, right here, a big old huge number line. And I'm going to start at 0, and I have to go all the way up to 5. And I'm going to go up to 5 not because of this 5 in the denominator, but because this number, this mixed number, is greater than 4, but it's less than 5. So I know I have to make a number line that goes up to 5. And let's break that up into my whole numbers. So here's 1, 2, 3, 4, and I didn't draw them very equal. You know, they're not evenly spaced, and that's okay. Mathematicians don't need their visual images here to be perfect, because we can use our mathematical imagination and fix things in our mind. Now, we know that each whole number is cut into 5 pieces. And how do we know that? Because of that 5 in the denominator. So we're going to cut each whole number into 5 pieces, and I'm trying to be as equal and evenly spaced as I can. Now, parents and teachers, big thing to care about, to really pay attention to with your students, is when we have a denominator of 5, that means we need to cut the interval into 5 spaces, but oftentimes, so basically we want 1 interval, 2 intervals, 3, 4, 5 intervals, all right? But oftentimes when students see a denominator of 5, they will create 5 hash marks, which actually creates 6 intervals. So be really clear with your students, and from an assessment point of view, please make sure that the students, when in this case it says cut it into fifths, they really are cutting into fifths and not accidentally cutting it into sixths, which is a very common mistake. All right, so there is our number line again. And so where is 4 2/5? Well, 4 2/5 would live right here. That is 4 2/5. So the idea is now what we need to do is we just need to count. So to go from here to here, that's 5/5. Here to here is another 5/5. So that means we're now at 10/5. From here to here is another 5/5. So we're now at 15/5. From here to here, where is another 5/5, so we're at 20/5. So where is 4 2/5? Well, that's at 22/5. So 4 2/5 is equal to 22/5. Doing this one, same exact process, although this time our number line is going to go from 0 to 6, because this number is larger than 5, but less than 6. 1, 2, 3, 4, 5, 6. And what are we going to cut each of our intervals into? Well, we're going to cut them into 8 pieces. And so at that point, I'm going to let you, parents and teachers, finish this problem, because I think I got you going enough. You're going to cut each whole number into 8 pieces, and you're going to keep going all the way until you've reached 5 3/8. See why I'm quitting here? because there's just so many dashes here. And you know that 5 3/8, 1, 2, 3, lives right there. And then your task is to just keep counting. Now, of course, we can do some shortcuts here, or not so much shortcuts, just a different way to think about it. Now, I'm going to do it a couple of different ways. So first off, we can think of 5 2/3 as really laborious. 1 plus 1 plus 1 plus 1 plus 1, 1, 2, 3, 4, 5, plus 2/3. All right? And now I can think of each one of these ones as 3/3. And why did I choose 3/3? Well, because the fraction here is in thirds, so I'm going to stick with my theme of thirds in this case. So I replaced each of the ones with 3/3, and now I have, oh my goodness, I have this big old long ugly problem. But if you really think about it, this right here, that's really 5 copies of 3/3 plus that extra 2/3. And if we wanted to add these up really quick, what would be the quick way to do it? Well, we would do 5 times 3, and that's 15, and we would get 15/3 plus the extra 2/3, and that eventually ends up being 17/3. So parents and teachers, what have we done so far? The previous slide, we taught students how to use a number line, because don't forget, if students are not digging this method right here, that's all right. Give students a number line, and in this case it would go from 0 to 4, and then they would cut it into 4 pieces, each thing into 4 pieces, because it's fourths. And they'd identify 3 3/4 is right here, and then let them count. 4/4, 8/4, 12/4 plus 3 more fourths is, well, yeah. What? Oh, yeah. Sorry, because I'm doing this problem. I was like, hey, why isn't the answer 17/3? So it's 4/4, 8/4, 12/4 plus 3 more fourths is 15/4, and that's exactly the answer they got right there. So the idea is, parents and teachers, we have 2 methods that we can now allow our students to use. 1, they can draw the number line, or 2, they can use this little bit of a shortcut. Now, this is leading towards the standard algorithm, so we do want to teach students how to be a bit more efficient and not have to always rely on a number line for their whole life. But parents and teachers, you get to decide when students are ready to give up their number line and move to a more official algorithm. Don't let the curriculum, or don't let Eureka Math push you around and force your kids to go into an algorithm too soon. Feel free to continue using that number line as long as your students need it. And here's just tons and tons of practice where students can really just think and try and think through it. Now, what I would recommend parents and teachers is, let the students go through a mental imagination of a particular problem. For example, so let's do 6 1/4, and I'll walk you through what I'm talking about. So we want students to say, so 6 1/4. So if I have 6 holes in my number line, and each hole is going to be cut into 4 pieces, so that means I would have 24 pieces. And how do I know that each hole is going to be cut into 4 pieces? Well, that's because the denominator here is a 4. So 6 holes, each hole is cut into 4 pieces, so 6 times 4 is 24. So I would have 24 fractions. So that's 24/4, plus I have to add in the extra fourth, so now I get 25/4. So you see how I kind of let my students think through the process, and they might need to draw a number line just to kind of keep it visual, but you'll notice I didn't fill it in. And ultimately, really, we're using that classic algorithm that us old old people were taught many years ago, which is 6 times 4 is 24 plus 1 is 25. And that's because we're thinking about 6 wholes. Each whole is cut into 4 pieces. 6 times 4 is 24. Plus we have this extra fraction, so that gives us 25 fractions, 25 fourths. And so that's the kind of idea that we want our students to be thinking through for these problems. We don't want them to just blindly use some algorithm or some trick. We want it to make sense. So if I wanted to do just one last problem, let's take a look at problem F here. So I'll zoom in a little bit. All right, so what is the whole point on this? Well, we have 4 whole numbers on our number line, and each one of these wholes has been cut into 5 pieces because it says so here. So 4 times 5 gives us 20 fractions, 20 pieces, and specifically that's 20 fifths, because 4 wholes each cut into 5 pieces is 20, so that's 20 fifths, plus we have this extra fraction here, 2 fifths. So we have plus that extra 2 fifths, and that gives us 22 fifths. Parents and teachers, don't let your students suddenly write 10 here because 5 plus 5 is 10. Don't let them kind of, while they're focusing on this new skill, forget that they're not supposed to add those denominators because these are units. These are labels, right? Like 20 apples plus 2 apples equals 22 apples. And that wraps up a really nice simple lesson, Grade 4, Module 5, Lesson 25, taking mixed numbers and turning them into improper fractions, or turning them into fractions greater than 1.